So who are you? What's your role and where do you work?
I'm Shyam Jeedigunta. I've been a long time contributor to Kubernetes and related projects, going to be close to a decade now. I work as a principal engineer at Amazon EKS and help build some of the largest, most reliable, efficient, durable clusters on the planet.
And what are 3 Kubernetes emerging tools that you're keeping an eye on?
Yeah, so it's been super exciting to actually watch a lot of new and emerging technologies at KubeCon. For me, I think the ones that I've been most closely following in the domains that interest me is VLLM is one of them. It's a super popular inference engine, and there's a lot of innovation going down deep in that stack. So I keep a close eye on that one. Cast AI is another, where they're working on a product for optimizing costs, obviously for GPU and accelerated infrastructure too. And job schedulers like Q, Slurm, these are projects that I think are really impactful for a lot of customers, especially enterprises that run jobs, Spark jobs, training, etc. at large scale.
What have been some of the biggest challenges you've seen when teams try to run machine learning workloads on Kubernetes?
The persona I like to think about is the ML researcher who has something working on their Jupyter notebook on their laptop, and now they want to actually take this run in production. Now there's all these layers that you need to sort of operate through, and there's a rather steep learning curve with each of those. So you need to figure out how to manage your infrastructure. How do you bring up the Kubernetes cluster with all the bits and pieces necessary for your compute storage network, and then you have to work at the next layer where you actually bring in all the ML capabilities, MLOps, being able to run pipelines, being able to schedule jobs, being able to auto scale your infrastructure. And then if you're running multiple of clusters across different regions, potentially across different accounts, and you have to orchestrate workloads across all of these, there's another added layer of complexity. So I think fundamentally the challenge here is the need to have a vertically integrated stack that operates through many different layers to actually get to business value. So this is one of the places where I think we need to invest a lot more, and we need to sort of improve standards for customers, reduce the undifferentiated heavy lifting.
Are there any tools, frameworks, or open source projects you've seen recently that you think are helping bridge the gap between machine learning and Kubernetes?
Yeah. So there are a bunch of awesome solutions for a lot of individual problems in this whole pie. For instance, if you want to manage your nodes, lifecycle, auto scaling, upgrades, etc., Karpenter is a great solution because it's something the community really loves. It's something our customers at EKS really love, and it lets you manage infrastructure, including GPU, accelerated compute, etc., really seamlessly. And then you want to use DRA for scheduling more sophisticated workloads, where you have to provision memory, GPUs, the other devices, and communication channels between compute. So you can do that in EKS too with recently launched DRA support, but there's a fair bit of configuration you actually have to do to get it working. For instance, you need to install the device plugins, the drivers, a bunch of other things, which, for instance, you don't have to take care of if you actually run with EKS Auto, where you get a lot of these pre-baked in. So you get capacity that's directly consumable along with all dependencies. And for the layer above, which is basically your job scheduling, orchestration, being able to manage ML pipelines, experiments, etc. I think there are a whole set of tools in the community which I think make this really easy, especially in the Kubernetes realm. For example, Kubeflow, MLflow are ones we see being used a lot. They make it really easy to declaratively specify the ML pipelines and experiments, etc., that you want to run. And similarly, job schedulers, multi-cluster schedulers like multi-queue, they make it really easy to not have to worry about sort of bin packing your jobs and workloads across multiple different clusters without compromising on efficiency.
If you were designing a production-ready AI ML platform on Kubernetes today, including training, inference, and auto scaling, what specific tools or architecture patterns would you choose and why?
Yeah, so the first thing is I really think you, as much as possible, should be trying to do declarative configuration, GitOps style practices. Just make sure that a lot of what you deploy is really reproducible. especially if you have your compute platform extends beyond the cloud to your on-premises, edge locations, etc. So you need consistency. You also need opinionated ways of launching these clusters. And for instance, on EKS, you can do EKS Auto, which supports GPUs and other accelerator types like Trainium and Inference on AWS. You get out of the box access to on-demand capacity, and it is elastic. You can choose to also have static capacity if you have sort of predictable jobs, predictable training style workloads. You can do container networking. You get access to some of the deep integrations we've built there around fast image pulls with Containerd using the seekable OCI that we recently announced. You get access to technologies like multi-ENI pods, where your AI/ML workloads, the pods of those workloads, can actually use multiple network cards on the underlying physical instances to actually unlock high bandwidth, high packet processing performance, etc. So try to use well-paved solutions. I think there's still some work to be done, both in the industry as well as in EKS to sort of make this easier for customers and sort of canonicalize some of these patterns with the vertical integration.
Kubernetes turned 10 years old last year.
Yeah.
You've been in the community for quite some time.
Yeah.
What do you expect in the next 10 years?
Yeah, so I keep thinking about this a lot, both in terms of the technology and the projects and the community, as well as in terms of my own career, where should it be heading in the next few years. I think one of the interesting ways in which I believe we are going to pivot is we built a lot of foundational technologies, a lot of common denominator fundamentals that so far have been useful for a lot of workloads. But we see a lot of specialization now. There's a lot of heterogeneity in hardware and capacity and environments you run these workloads in. And there is a need to make this easier for customers to consume across these heterogeneous environments. And I also think it is important to invest a lot in a lot of hyper-focused piecemeal solutions that solve what may seem like esoteric problems. For instance, how do you migrate a GPU node to another GPU node as fast as you can? How do you take volume snapshots and potentially reduce the amount of time that your GPU cluster for training, for example, is not being utilized? And so there's definitely a lot of scope for specialization and solutions like these.
And what's next for you?
I'm going to be working and chipping away each of these problems. I'm going to try to help as much as I can, both the open source community as well as at EKS, to make lives of our customers easier.
And how can people get in touch with you, Shyam?
You can reach out to me on LinkedIn, on Kubernetes Slack, on wherever you can find me. My handle in most of these places is Shyam JVS. On LinkedIn, it's Shyam Jeedigunta. Or if you find me near the AWS booth or in the open source project pavilion or one of the hallways, feel free to come say hi.